Hello again, guys. So here I want to show you something which I think is quite useful. So basically, imagine you have an object which is maybe like coming into the atmosphere or like interacts with some kind of medium. You know, like maybe there's some water bubbles that you want to emit of something which is like swimming underwater, or there is a rocket which is coming to the atmosphere. So basically, you want to like make it react to the medium it's moving through. So if it's this kind of a mock-up airplane here, let's say something like this. So you have this stuff that gets emitted from the leading edge and is trailing in some kind of a nice way. So getting an emitter like this is very easy with Krakatoa, and something that we like doing. So let me show you how this works. You have a simple plane which is facing the object like this, and I have it parented to a helper which is itself parented to the object. I think that's yes. So I can kind of rotate this helper. You can see that the leading edge stuff, these particles here, are getting moved. If I move all this kind of stuff, then you can see that it's just a plane, and we have put appeared surface particles on this plane. So the next thing we do is we simply project them from the plane on the object. So this is done with some magma. Let's see here. Always awesome and fun to do magma stuff. So it's very simple stuff, it's projection. So to project, use the intersect ray against the geometry of the plane from the world space position of the particle towards the normal, because you get normal from the plane in the direction, and pretty much put the particle at that position. So because the geometry is a bit bigger, the plane than the plane, funnily enough, paradoxically. So the plane is bigger than the plane, and some of the particles would not hit with that array ever. So I use that is valid here to simply switch. If the particle does hit, the array does hit, then I use the hit position. If it doesn't hit, I use the original position. So nothing changes much. Now the cool thing is that we can also add some offsets on normal. So imagine you don't want your particles to be exactly on the surface. Maybe you want to do some collision with it or something. So you want to offset them a little bit, and you can simply get the normal at the collision point from here, and you can multiply it by something, and you can add that to the position vector. So it's a bit offset. And yeah, use that for the switch, and eventually convert everything back into from world space to object space, and use this for position. Now again, I can use this condition, which is like if the particle is hit, to simply find out which particles have remained here on the plane and delete them because I don't need them anymore. So I use the is valid and then convert it to a float because it's a boolean, subtract 1 minus because I want to delete the particles which actually are not hitting, and I get the selection, and to just get some more information from what I have, because there's still more data to be had. So this distance that the particle flies before it hits is also interesting. So I guess you might want to make the front part of your object emit a little bit, harder than the back part. Maybe like here the flames are more intense, or yeah, like the water bubbles or whatever are biggest. So you can easily do that, get a distance and add something to it. This is basically this offset here, because there is some distance before even the first point. Divided, this is basic normalization. Divide, clump, and subtract is just reversing it. So I can have the white stuff at the front and at the back. and convert this to a vector and put it to the color channel. So I just need to hit the Krakatoa delete on top and select particles getting deleted, and all of this stuff is just where I want them. So again, I can, if I, let's say, like space shuttle, or space shuttle is a bit antique now, like the SpaceX Dragon ship is approaching the atmosphere, and it kind of glides with the flat side downwards. So you can like rotate this a little bit. So I get eventually this, but I thought, like, why not? Let me just show you also this thing, because it's a little bit cool. Just so we don't only make emitters, this would be a bit anticlimactic, you know. Don't want to be boring. So let's also do something else. I have here Stoke objects. Stoke objects. I don't know if you guys using it. Stoke is super sweet. We use it pretty much all the time. Like since we started with it, it turns out it can do too many things, so we just use them. In this case, I'm using this as a particle simulator. So I have a field, which I define. I'm going to show you how. And I run all the particles through it. Stoke is super fast with just letting particles run through fields, and you can have very nice motions created by fields. So you can see here, the stuff is quite fluid and cool, but there is no fluid simulation happening here outside of the simple fluid that Stoke makes, which is simple, hence fast. So how to make an interesting velocity field? Again, a magma thing, so let's just look into that. And what is happening here is that here in the start, I blend between two turbulences. So if you see here, I have two winds, and they have different scale, quite classic thing that we've been doing since the old days. But the cool thing is that because I have a field here, well, let me isolate maybe, yeah, because I have a field, I can actually blend these in a smart way that is, let me see if I can show. I can blend them in a smart way so they don't apply everywhere in space with the same amount. This is something which is really bothering me with this just turbulences at max. They don't have spatial variation. You know, they have the same character everywhere, which you can easily fix with the Stoke field, because you can create a noise based on, like, seeded by the positions of the voxels, and you can blend the turbulences in a way that you know, applies more of the bigger scale turbulence in the white areas and the smaller scale turbulence in the darker areas. And this allows you to have a much more visually interesting result than just, you know, like a tired old single wind playing back. And this looks much more interesting, much more organic. So that's very easy to make. I have the input field with the two winds, and there is a noise generator in Magma, which is quite fast and nice. So this is much faster to use rather than like texture lookup noises or anything. So I use the position to seed the noise here, and you can see I divided by something. So it's like turbulence blend scale. There's a float which I have exposed, so the field has gets inputs. Oh, you can see here exposed parameters, which I can show you later. And this gets fed to the noise, and because the noise is creating stuff in the -0.5 to 0.5 range, I add 0.5 to it to make it between 0 to 1. And I use this 0 to 1 value to blend between the two turbulences. You can also put in a curve here or anything like this to make the whole thing like more to your liking, to tune it. And then I multiply by something which is defining the strength of this part of the effect. So the second part of the effect, let me see if I say here turbulence strength 0, and I say give me velocity, what's going to happen? I turn off normalize. So you see here the other components. This is, let me just quit isolation mode. So this is around the airplane. So what I want to have is that the particles don't interpenetrate to the airplane and also get like a bit repulsed from it, you know, to get this kind of a wind tunnel or whatever effect. Because the Stoke field does not inherently have like something like collision, but you just easily make one by creating a strong velocity near an object in the direction of its normal. So this is pretty much as good as a collision. So to make this, I use the nearest point node, and again, like towards the geometry of the plane, looking at from the position of the voxel, and I get the distance. I get the absolute because it's signed on inside, outside. Usually absolute, good enough for me. And I can normalize it. So I have radius that I can dial in later, and I can even put in a curve. So near the object, the effect is very strong and kind of tapers smoothly towards the end of the farther away from the object. And of course, this curve is very cool that you can tweak exactly how this stuff happens. Sometimes it's quite sensitive, because if you want to have something that's more like a collision, you need a very low steepness curve, and if you want something that is more like a fluid influence of the object and of the object influencing the fluid around it, you need like a less, kind of more like a humped curve, like less steep. Maybe it's like steep in the other direction. So again, I subtract that to just reverse it, because I want the actual force to be strongest where the distance is lowest. And then and this is basically giving me the strength of the force. So to get the direction of the force, I vector subtract the hit point, the nearest point position, and the voxel position. So I pretty much get the vector between where I'm creating at the voxel, I'm creating the force and the geometry. I normalize that, so I have like a one length vector, and I multiply by the strength of the force. And then eventually I also multiply it once again by like a general multiplier, which is simply something that I can expose and I can play with after I have closed up all of these crazy things here, and I'm just looking at stuff and drinking a nice Bulgarian craft beer and enjoying tweaking my effect. So both of these like these elements, these components, velocity components, get added and they get sent to the velocity field, to the velocity channel of the field. Bobo would be correcting me very quickly if I'm that careless. So you can see the field here, and you have different options to the viewport display, but now we don't need the viewport display anymore. We can just use these things here. Actually, let me show you the I wanted to not mask it, and I wanted to show dots. So let's see the turbulence blend scale that I told you about. So if it's 2000, this becomes much, like lower frequency, bigger scale. I think I hit 600 before, but that's how it works. It's simple and nice. The radius, I want to mask my density now. So the radius, check this out. If I put in here 600, I get an influence of the force which is pushing away from the surface at a much bigger radius. So stuff like this, quite easy. Turbulence strength, how much the turbulence component is affecting the whole thing. You can see I tuned to 0 just so I don't get all the crazy vectors which are showing me like in which direction forces go. Because I want to show you only the ones near the airplane. So okay, turn the viewport display off, and then in Stoke, simply pick up the PRT surface that we made for the emission zones, and then pick up the field that we made for the velocity field, hit the magic create fluid motion button, and then just simulate. Usually I tweak my effect locally. So you see I have, let's see, made simulate from like 15 frames before the whole thing starts, but the cool thing is you can only cache the part that you need. I have some substeps here because it's quite fast, the effect, and I want to avoid any jittery, kind of like any streaks. And I pick up the texture coordinates from the airplane, and I use this to displace color, just to have something for a color. I can use some of the stuff also in velocity or anything. Eventually, when I render, most times I try to create some kind of interesting effects with data that I have picked up from the original object and from some other sources from anywhere I can. So you can see here, especially on the wing, the way the wing is being kind of affecting the fluid, but generally, general niceness, I think you could say. So yeah, that's it. It's a very useful setup that we've used on multiple occasions, and I hope you guys have enjoyed it. Ciao!